Welcome back. This is the solution for problem 1b from Superquiz 3. So again, we're given a sequence, in this case it's B, and we're asked to compute the limit of this sequence, right, if it exists. Okay, so last time we actually found there was no limit that diverged. Maybe this time we'll get luckier. We do get to assume things like the sequence 1 over n to the k is going to converge to 0 for all k positive, and any properties of sequences or series that we stated in class or on the homework. So one of the things that we have seen with sequences and series is we can break up sums and products and quotients provided all of the limits exist. So what I want to do here is look at the three pieces to this puzzle individually. So the first piece, this is pretty easy. That's a constant number 3. As n changes from 1 to infinity, this 3 does nothing. Okay, fine. What about the next piece? We have the arcsine of n plus 2 over 2n. So let's take a look at that. So the arcsine of n plus 2 over 2n. Now the arcsine is a continuous function. So if I am looking at a limit as n goes to infinity of the arcsine of something, I can look at the limit of the inside piece, right? So the continuity of arcsine allows me to consider the limit as n goes to infinity of the input to the function, which is n plus 2 over 2n. Now, I can do a very nice transformation of this by multiplying the top and the bottom by 1 over n, right? Largest degree of n here. And when I do that, I'm going to have the limit as n goes to infinity of, okay, on the top, I will have 1 plus 2 over n. And on the bottom, I will have 2. Oh, that's nice. All right, so this 2 is not going to change as n goes to infinity. So I could pull that out, and I have the 1/2 times the limit as n goes to infinity of 1 plus 2 over n. Now again, I have a sum, right? And so I can look at these individually, and as long as both limits exist, I'm going to be fine. Now this 1 has nothing to do with n, all right? That's going to be okay. What about the 2 over n? Well, as n goes to infinity, 2 over n goes to 0. In fact, if we think about just ignoring the 2 for a moment, we're back to our assumption, right? We know that 1 over n to the k, which in this case our k is 1, is going to converge to 0 as n goes to infinity. Of course, multiplying by 2, right? Again, we have a property of sequences, says if you know you have a convergent sequence, and you multiply by a constant in every term of that sequence, you just multiply the limit by that same constant. Okay, well in this case the limit is 0, multiplied by 2, it's still 0. So in total, we're going to get 1 plus 0 as our limit, and so this ends up being 1/2. Fantastic. So the input to our arcsine function is going to 1/2 as n goes to infinity, which means, so this implies that the limit as n goes to infinity of arcsine of n plus 2 over 2n is equal to the limit as n goes to infinity of arcsine of 1/2. Okay, well there's no n anymore, so this limit is superfluous, right? So we can just say this is equal to arcsine of 1/2. So we just need to know which value of the sine function gives us 1/2, and that's equal to pi over 6. All right, so we know that this second summand in the numerator is converging to pi over 6. All right, third piece, cosine of 2 pi n. Well, man, that 2 pi n, that's weird. Maybe we write down just a couple of terms, right? So like when n equals 1, I get cosine of 2 pi. Cosine of 2 pi, that's actually 1, right? That's just, you're on the unit circle. That's 0 radians, but that's also 2 pi radians, right? There's 1. Okay, well, what about cosine of 2 pi times 2? That would be cosine of 4 pi. Wait a second, that's the same spot on the unit circle. That's also 1. I think I see what's going on here, right? If we make n 3, I'll get 6 pi, which is, again, yeah, same spot. So in fact, cosine of 2 pi n is always equal to 1, no matter what our n is. So in particular, the limit as n goes to infinity of cosine of 2 pi n, well, that's going to equal 1 because it's 1 at every single step. So this goes to 1, but more accurately, it equals 1. All right. So again, using the property of sequences and series, that we can break things up over sums and quotients, provided that all the individual limits exist, we know that this sequence B is going to converge to 3 plus pi over 6 divided by 1, or 3 plus pi over 6. And there we go.